Okay, this is, let's continue with the 12th question. You have a frictionless surface in which there is a triangular wedge B, okay, and you have a pulley which is here, another pulley here, and a rope that runs across through this. It goes like this, and comes and gets attaches like this. Okay, and yeah. There, and from here the rope is attached to another block. The block is A and there is a wedge B, and it's been given that the wedge is already moving to right side with an acceleration of A. So when it does that, obviously the A will rise up. Okay, so let's call this as X, and this is X, and this is Y, and this is Z. You know, X and X, when the A is moving right side, obviously X is going to increase. So X is increasing, Y is decreasing, and Z is a constant. So when you add up everything, 2x plus y plus z is equal to a constant. So 2 into dx by dt plus dy by dt, which is decreasing of course, but I'm not putting a negative sign or anything, plus differentiation of dz z is a constant, so it's 0. So it's equal to 0. Double differentiated plus d square y by dt square is also 0. This shows that 2 times velocity of x plus velocity of y is equal to 0, but you already know that the velocity of x is nothing but the velocity of the wedge, which acceleration of the wedge, sorry, this is acceleration of the wedge. 2 times acceleration of x plus acceleration of y is equal to 0. You already know this is a, the ax is a, so 2a is equal to minus ay, so ay is equal to minus 2a. That shows that the acceleration is a decreasing acceleration, and this is the acceleration with respect to the ground. They are asking two part of the question. The second part is with respect to the ground. That is the answer for, this is the answer for the B part. And then the first part is find the acceleration of the block with respect to the wedge. You know the block is going to rise up in this direction while the wedge is going in this direction. You know the acceleration of this is A and this is minus 2A, and so the resultant will be in this direction. You can ignore because according to parallelogram law, the root of A square plus B square plus 2AB, where 2 into magnitude of A into magnitude of B into cos theta. Since the wedge here is theta, so this will be 180 minus theta, and according to parallelogram law is A square plus 4A square plus 2 into 2A into A, the magnitude of both acceleration, into cos 180 minus theta, and a cos 180 minus theta is again minus cos theta, so therefore 5A square minus 4A square cos theta. From this A can be taken out common, 5 minus 4 cos theta, and that will be the acceleration of the block A with respect to the wedge B. So then this is the answer in here is they seem to have exchanged both answers. The A's and B's has to be interchanged. So if you disagree with me, you can tell me in the class, but that's the clarity I have. So let's go to the 13th question. You can read the question here. The questions have been printed. You have a movable pulley and a fixed pulley, of which there is a bead here of mass m, and there is a thread which is like having length L is equal to, this part of the length is 18.75 meter. There is a block B, and it's given that this mass is 2m. So let's mark the tension. It's the same rope, so T, and a T. And so we can find, let's call this as A1, let's call this as A2. So A1 by A2 is equal to T2 by T1, which is T by 2T, and T get cancelled. So you know that A2 is 2 times A1. So since A2 is 2 times A1, if I'm going to call this as A, this is going to become a 2A. So that is the first part. And the second part is, if you see, if the thread is going to, this rope is going to have an acceleration of A, obviously there will be an upward acceleration A, while the bead here is going to move down with an acceleration 2A. What we have found is the acceleration of the bead. So then that will move with an acceleration 2A. So there is a relative acceleration between the rope and the bead. So the relative acceleration is 3A. And that has to cross this with a relative acceleration. So 18.75 S is equal to UT 0 plus U0 half 3A into T square. Next, the second part of the question, they are asking what about at that same time, how much would B go down by? So you know, only when B goes down, the thread will go up, and so then therefore the bead will come down. So I hope you understood that concept well. So L at x is equal to, initial velocity is again 0 plus half A is just A here into T square. So dividing these two equations, you get 18 by 7 by x is equal to half and half, a and 8, t square get cancelled, 3. So 3x is equal to 18.75. So x is equal to this 6.25. So you'll get this. So let's go to next question. It's not an easy question. That is a very, very difficult sum. I hope you can understand. If you don't follow it, I can teach you in the class. There is a mass M1. There is a pulley here. And this goes like this. And there is a peculiar sum here. This is a pulley A and this pulley B. And in pulley B, you have two masses, M2 and M3. Okay, considering M3 is more heavy, because the diagram shows that way, I feel this is going to be like this. But you know, it's going to have the same tension, therefore the acceleration will be the same, but just that it will be in the opposite direction, because the ratios of the tensions and accelerations would be the inverse, and so it's T by T, so A and A. There is no friction, so if this is 2T and T, there will be a 2T and there will be a 2T, and you know that 2T is equal to M1 into let's consider this acceleration as a0. So then m1 into a0. So t itself is m1 into a0 by 2. And that gives you a first equation. And you know that when the most important part about this is when this block is going to move towards the right, this entire pulley is going to go down. While the pulley B is going to go down, the mass m2 is going to go up. So there is the pulley is going down with an acceleration a0, the mass m2 is going to go up with an acceleration a, so it's a plus a0 is the relative acceleration, or a0 plus a, let's call it a0 plus a, and here it will be a0 minus a, relative acceleration of m3, because the pulley is also coming down b and m3 is also going down. So then there is a a0 plus a and a0 minus a are the relative acceleration. So let's do the vector diagram for this. There will be an m2g which is acting down. So m2g minus t is equal to m2 into a0 plus a. Similarly, m3g which is acting downward. So m3g, the thing is, in this sum what is difficult is you can't imagine that both m2 and m3 are eventually going to only drop down, because m1 is moving towards the right, and it eventually, how much ever this is going to go up, it is only going to come down. That's something that I cannot think of, to be very honest. So then therefore, considering that m3g minus t is equal to m3 into a0 minus a, but you know the value of t, you can substitute here. So first equation, m2g minus m1 into a0 by 2 is equal to m2 into a0 plus a. The second equation also, m3g minus t which is m1 into a0 by 2 is equal to m3 into a0 minus a. So one second, hold on. So the substitute பண்ணியாச்சு. இப்போ வந்து you can bring the m3 down, so it will become m2 by m3. No, m2 by m2. So it will be g minus m1 by m2 into a0 by 2 is equal to a0 plus a. And the next equation is g minus m1 by m3 into a0 by 2 is equal to a0 minus a. A and a gets cancelled, you get a 2a0, and it will become 2g. And what is common here is m1 into a0 by 2 into 1 by m2 plus 1 by m3. So then you can consolidate a0 and a0. So 2a0 plus m1 a0 by 2 into 1 by m1 plus 1 by m2. So from this you can take a0 completely out, or 2 plus m1 by 2 into 1 by m1 plus 1 by m2 is equal to 2g. So a0 itself is 2g by 2 plus m1 by 2 into 1 by m2 plus m3, sorry, m2 plus m3, 1 by m2 plus 1 by m3. But the option la pathana in the 2-way irukadhu, so therefore probably they would have cancelled off the 2. So this will become 1 plus m1 by 4 into 1 by m2 plus 1 by m3, and that will be the option of the acceleration of the mass m1, which we have assumed as a0, and we'll get the answer like this. Okay, so let's go to next question. The next question is the 15th question. The 15th question, see, as it moves on, the questions, everything is becoming very, very hard for me. These sums are very hard for me. I was able to do certain sums that I found a little easy, but these are the sums that I need to think and upload videos. Let me spot at least those sums that I can do. Let me try to do. Maybe this looks simpler, so let me try something which is at least looking simple instead of doing really complicated stuffs. Okay, so then there's a pulley and there's a 2 kg mass, and there's a rope that runs like this, and there is a force F is equal to 20 Newton, and this goes, and this is also connected to the roof, and this is a 2 kg block. Okay, there's a 2 kg block, and this is the diagram. Okay, yeah. It's an easy sum only. As I'm applying a force of 20 newtons here, the tension above will also be 20 newton. If this is going to be T, it's the same rope, so this will also be T and this will also be T. Let's initially mark it as T, and the 2 kg is acting downward. And if you pull it like this, the acceleration, these both will go up. Okay, so in this free body diagram, you know that's up. Okay, so now can I find the ratios of the acceleration? Let's consider this is A1, A2. A1 by A2 is equal to T2 by T1, which is T by 2T. So then therefore 2 times A1 is equal to A2. So if supposing this is A, this is going to be coming down with a 2A. And now let's do the free body diagram, which is in here. It's going to go up. So 2T minus 20 is equal to 2T minus 20 is equal to 2 into A. This is one equation, and according to this free body diagram, there is 20 is equal to T. T is equal to 20. Substituting here, 40 minus 20 is equal to 2A. 20 is equal to 2A. A is equal to 10 meter per second square. So easy sums is fine. Very hard sums, I'm just wanting to deal with it, because not much of a pulley sums are being asked in exams. So as it progresses, when it gets really tough for me, I'm just trying to not do those sums. I'm addressing only those it is within my capacity to do. 2 blocks of mass 5 kg and 10 kg are connected by a string passing over a pulley B. Another string connects the center of the an upward force F is applied at the center of the pulley A. Okay, so let's this seems, I think I can manage and do this. So that's A, and there is see the other sums which are tough, I can do it provided I see the solution. I'm right now not looking at the solution, so I'm just trying to think and within my ability, because at the end of the day, if it's very hard, even if I learn now, I'll be forgetting later. Let me be very honest. Okay, so this is capital M. So with what I have taught, I should be able to do the sum. So that's what it is. So let me first think about this. So let me try the sum. Let's see, only single rope is going across here. So if this is T1, we can call this also as T1. But definitely this is going to become 2T, because it's T1 and T1. So it's got to be 2T. Okay, let's call this as T and T. So this becomes a 2T. And it's the same rope which goes here also. Obviously this has got to be 2T. Okay, and you know that there is a force F on that. Okay, I'm just trying. You know, therefore that force with F has to be equal to 40. F is equal to 40. Yeah, F is equal to 40. Therefore T is equal to F by 4. And 2 blocks. Okay, find the acceleration. Okay, an upward force F is applied at the center of the pulley A. Both the pulleys are massless. Find the acceleration of the block M, small n and capital M. You have to find the acceleration of these two. Okay, so we are trying to find the acceleration of these two. They have given find the acceleration of the block M and capital M if the force is, in the first case, is 100 Newton. Okay, let's do the 100 Newton stuff. Okay, so then therefore tension will be, this is 100 means 100 by 4, so it's 25 Newton. Weight of the block as you can see, they have given 5 kg, capital M is 10 kg and small m is 5 kg. So then this will be 50 Newton and this will be 100 Newton, which is acting downward. And can you see that definitely this is 25 Newton is this force or this tension, this tension T is 25 Newton, which is not sufficient enough to carry it up. Therefore, the blocks will remain on the floor and will remain stationary. So that is the answer. So 0, 0. No, both the blocks will not move. Let's go for the second case. The second case, if you see, they have given 300 Newtons. So the same formula, you put F is equal to 300. So F is equal to 40 does not change. So F itself is becoming 300 is equal to 40. T is equal to become 300 by 4. What is 300 by 4? It's 150 by 2, which is 75. The 75 Newton will be good enough to lift the 50 kg. Not be enough to lift the 5 kg and not the 10 kg, right? So then therefore the 10 kg will have 0 as the acceleration, while the 50 newtons would accelerate up. So then it's up T minus 50. T minus 50. T itself is 75. So 75 minus 50. So T itself is 75 minus 50 will be equal to 25. It's equal to M into A. So M is 5 into A. So this is 25 is equal to 5A. So A is equal to 5 meter per second square. That answers the part B, section B, where the answer is 5 meter per second square. And so next case is when 500 newtons. Obviously this force is going to become 500. 500 is equal to 40. T is equal to 500 by 4, which is 4 ones are 4, 4 2s are 8, 125, which will be sufficient enough to lift both small m and capital M. And you know that the 50 Newton, 100 Newton, both of them are going to go up. So T minus 50, which is 125 minus 50, is equal to M into A, which is 5 into A. And similarly 125 minus 100 is equal to the kg is 10 into A. So you have this. So this will become 75 is equal to 5A. A is equal to 75 by 5. 5 ones are 5, 5 is 25. So acceleration is 15 meter per second squared. And for the next one is 10A. So 2.5 meter per second square will be the upward acceleration. So that completes the sum. This sum, I'm finding these kind of sums easy. Certain sums I'm finding it very, very complicated. So let me do this. Let me try this again. So let me draw this. You have one force of 10T which is getting applied